There we go. All right. So we have two different types of parent graphs, right, when we talk about these rational functions. And one of them has a squared in it, and one of them does not. So this is the squared one, looks like this. And then this is the one that does not, right? Okay, so when we look at the last example problem, it's got the squared on the bottom. And so that means that this is the table that we're going to use. So I'm going to go ahead and write down the table from that one. It was -2, 1/4, -1, 1, x equals 0 was a vertical asymptote, then 1, 1, and then 2, 1/4. Now, before I even get started, I can already tell what the new horizontal asymptote, or what the new vertical asymptote is. Can anyone tell me what it is? It is 2. So if I look right here, I'm just going to do the opposite sign of that. That says -2, so I'm going to say I'm thinking about it moving to the right 2. So I'm going to say my vertical asymptote is 2. And then I can go ahead in here and put a vertical asymptote at 2. Does anyone know what the horizontal asymptote is? Not 0, it's 4. Good. So it was 0 in the original problem. But this one has a +4 on the end. That means that the horizontal asymptote is y equals 4. Okay, so let's go through and do each of these transformations. Can somebody tell me in words what our transformations are? Okay. And then one more. Reflect over x. Okay, and then which transformation do we have to do to the points first? The reflect over x, because that's a multiplying transformation, and we always do multiplying before adding and subtracting. Okay, so when we reflect over x, we multiply, and what do we multiply? The y-coordinate or the x-coordinate? So if you reflect over x, you take something that was up, you reflect it over x, and you move it down. So we're going to multiply the y-coordinate. What are we multiplying the y-coordinate by? -1? Mm-hmm. All right, so -2, -1/4, -1, -1, 0, 1, -1, 2, -1/4. All right, and then what do we do? Yeah, up and down, left and right. So we are moving to the right 2, which means +2 to the x value. So we're going to say 0, 1, x equals 2, 3, and 4. All right, and then what do we have to do next? Up 4. So if we're at -1/4 and we go up 4, 3 and 3/4. Good, 3 and 3/4. -1 go up 4. 3. -1 up 4 is 3 again. And then 3 and 3/4. Okay, so I'm going to say add 2, add 4. Okay, so to graph the points, I've got 0, 3 and 3/4, I've got 1, 3, 3, 3, 4, 3 3/4. There we go. We okay so far? Okay. So for the domain, we have everything except for what number? What's the one X value that we're not allowed to have? 2. And this is just like, if you guys remember what we've been doing the whole unit when we talk about excluded values, it's the opposite sign of whatever factor is on the bottom. If we were looking at this as a factor that's on the bottom, we would think of this as 1 over x minus 2 times x minus 2, right? And so on the bottom, we have a factor of x minus 2. We do the opposite sign of that. That's just 2. And so that means that's the excluded value, is 2. We can't have that. So I'm going to say the domain is everything except for 2. So in interval notation, I say negative infinity to 2, and I put a parenthesis around it because I'm not using it. And then I say 2 to infinity. What do you guys notice about the y values? If we go from down to up, do we have negative y values? Yeah, we have a down arrow, so we know we start with negative infinity, right? And we've got all the negatives. We go up, and we've got 0, we've got 1, we've got 2, we've got 3. And then where do the y values stop? They stop at 4. Is there any y value above 4? Nothing. This graph does not go above 4. So I'm going to say we start at negative infinity. We go up to 4. Do we include 4? Do we do a bracket or do we do a parenthesis? Parenthesis, because it's an asymptote. We don't actually touch that line. We get close to it, but we don't touch it. So you're going to see 3.999999999. You are not going to see 4. Okay. How are your brains? Good? Okay. X-Intercepts. We do need a calculator for this. So if you do not have one, go ahead and go grab one. Thank goodness I keep mine in my purse right here. Yeah. I mean, you never know. You never know when you're going to need a graphing calculator. You know what I'm saying? No. I can fully analyze the prices. Yeah. I can write equations. I can do all the things. Wow. All right. So I'm going to do -1 divided by x minus 2 squared plus 4. All right, we all got it graphed? Do we remember how to put the fractions in? Alpha y equals, so green button y equals to get those plugged in.
Is it the 4 or not?
The window that we had on here was a lot smaller than our normal window, so I'm going to go ahead and hit the window button, and I'm going to change the window of my calculator to match the window of my paper. And so what should I do for the window of my calculator? Yeah, I'm going to change them all to 5s instead of 10s. Now, your calculator does not graph the dotted lines. You have to be the one to do that, okay? So if you're looking for that, you're not going to see it. But does that look like our graph? Yeah, they drew more of it than we did, but it looks like our graph. So one thing to be careful is that just because my lines don't go down further, just because I drew those arrows, does not mean there are no x-intercepts, right? Because I really could have drawn this all the way down to have those x-intercepts. So the x-intercepts are going to be very close to 2, a little bit less than 2, a little bit more than 2. Do you guys see that? Okay. So we're going to do second trace. Actually, do you guys like doing the second trace, or do you like putting the 0 in? Second trace? Okay, so second trace. Option number 2, left bound, right bound. So there's my left bound. There's my right bound. All right, so 1.5. I'll go ahead and do the other method for the other one. So second trace, option number 5 for the other one. I'm just going to see where they intersect. $2.5. Say it again? We do not use the U. The U only gets used in interval notation, and this is technically not interval notation because we're just writing an X and a Y coordinate. Okay, good question. All right, how do I find the Y-intercept? Yeah, so you can plug in 0. We actually already know the Y-intercept because it showed up on our table. So you can say 0, 3 3/4. If you just did it in your calculator gave you 15/4. That answer is also fine. 15/4, 3 3/4. If you do not like fractions, do you guys remember how we could make this give us numbers that are not fractions? You do it on this screen. You get to the very end of your equation. We talked about it a long time ago. You hit the math button, and you go to number 2, and you tell it, give me answers as decimals. So now if I do it, I'll plug in, put a graph. Now if I plug in 0, it gives me the answer as a decimal instead. Okay. All right, so I'm going to say 0, 3.75. Okay, max or min, are there any mountaintops? Are there any valleys? No. All right. If I put a stick figure right here, what is that stick figure doing? Walking downhill, goes down into the abyss, catches the coronavirus, and is gone forever. Awkward. All right. And then after that, another stick figure has gotten the coronavirus but has been okay, has crawled out of the abyss. And there's a new stick figure right here, healthy after having contracted the coronavirus. This person is the person making all the memes that we've been seeing on the internet because they have overcome. You know what I'm saying? Oh, you guys, I have to show you this, actually. Hold on.
You want to see if
I have to. NBA 2020. You know, get it? Okay, sorry. All right. So this guy's coming out. What's this guy doing? Increasing. Crawling up. You know, he's a little weak from the coronavirus, but still alive. Okay. So what is the X value? What is the X value of a left arrow? Negative infinity. And then this arrow is going down, but the down is the Y coordinate. It's not like the X coordinate. If we think about this, it's getting closer and closer and closer to the purple line. And what X value did I put my purple line at? 2. So it is decreasing from negative infinity to 2. Okay, then we have this guy increasing. What X value does he start increasing at? 2. So at the purple line. And then it goes up to a right arrow, which is infinity. And so the increasing is from 2 to infinity. Okay. Is this graph continuous? No. Now, I'm going to add one little extra thing today. This was not on the video notes at all, okay? What we're going to do is we're going to say what part of the graph messed it up. my teacher stare stays current from this table. This table keeps my teacher stare practiced, ready to go. All right. What is the X value that ruined the continuity of the graph? It was 2. 2 ruined it. So we're going to say discontinuity at x equals 2. Discontinuity at x equals 2. Did you guys notice that the discontinuity is also the excluded value? That's not a coincidence. Excluded values create discontinuities. They are what make it so the graph does not, because you can't trace it with your finger if it's not there, right? And we were saying that a continuous graph is one you can trace with your finger without picking up your finger. The excluded value is what forced us to have to pick up our finger. Okay? So we have a discontinuity at x equals 2. We know that because there was an excluded value there.
Are you ever going to have a slope, like a fraction, or
for the discontinuity?
Yeah.
It's possible.
If it's correctly flipped?
If it was like this, then it wouldn't be a discontinuity because you'd be getting all these x values. Does that make sense?
Oh.
Okay. The idea of continuous and discontinuous gets a lot more complicated in pre-calc and then especially in calculus. But for us, it stays pretty straightforward. For us, it's like, yep, that value's not on the bottom. We can't have it. Therefore, it's a discontinuity, and I move on. Yeah. All right. End behavior. This end behavior is a little bit different than the end behaviors that we have looked at in the past because the arrows do not go up and down forever. Did you guys notice that? So as we look to the right, as we look to the left, it's not going up, it's not going down, it's going to an actual number on both sides. Yeah, what number is it going to? 4. So as we go left forever, it's getting closer and closer to the green line. The green line was at 4. As it goes right forever, it's getting closer and closer to the green line. The green line was at 4. So the end behavior goes to 4 instead of going up or going down. Harlan, I'm about to slam that against the wall. Marvelous. Let's just put it all the way away. Bottom of your bag. All the way down there. Perfect. Question. Yes?
Is it always going to be your horizontal?
Yes. So if you want to write a little note to yourself, that's not a bad idea, that for end behavior for these graphs, it is always the horizontal asymptote. So you can actually find the end behavior without even graphing the problem. So one thing that is interesting in pre-calculus is they call horizontal asymptotes, they call them end behavior asymptotes because they tell you the end behavior without you having to do anything in a calculator. Okay, how are your brains doing? Little mushy, but kind of okay?